For this video, we are going to cover compressions and expansions. So, we've done translations, we've done reflections, and now we're going to be doing compressions and expansions, which is a stretching, or I guess a thinning, of a function. We need to know y is equal to a multiplied by f of x over b. The a, because it's on the outside, refers to something we do vertically. And this is either a vertical stretch or a compression. So vertical stretch or compression. Okay? Or if you want to use the language, vertical expansion or compression. For B, this is a horizontal expansion or compression. I'm a bit lazy here, so I'm just going to duplicate here. So now, let's say we have a graph that looks like this. Let's go with I guess it still won't let me do that. So let's say we have this. And then this. Now, whatever is on the outside, all we have to do is just multiply. And same thing over here, whatever's under here, the b we just multiply. Now, for a and b, if they are bigger than 1, we call that an expansion. If they are less than 1, we just call that a compression. So if this is our original function, let's go over here. We have nothing inside the f of x, and we only have something outside, and it's multiplied, so we know that it has to do with a vertical compression or compression. Because 2 is clearly bigger than 1, that means we're expanding. And what that actually is just that every y value we are doubling. So we're stretching it up. So now these are the original points here. We're going to multiply every single y value by 2. So now instead of here, which is negative 1, 1, it's negative 1, 2. Instead of negative 2, positive 2, it's negative 2, positive 4. And we're going to keep stretching. This is multiplied by 2, so it becomes over here, and then here and here. This is 0, so 0 times 2 is still 0. Okay. And that's what your function looks like. Okay. We are stretching it. So it's almost as if we're, how do you say? We're just making everything double. Okay. So it looks a lot thicker than it actually is. Now, remember our original, let me write it on the same graph in case you forgot. Our original looks like this. There. There. So every single point, instead of, what do you call it? Instead of multiplying by 2, we're multiplying by half. And this is our a value, and this is a compression because it is lower than 1. So a couple points that I want to use are here, here, and here. You multiply all those by half. 2 becomes 1, 4 becomes 2, 6 becomes 3. 0 is still 0. We do the same thing for all these points over here. And there you go. Your new function is compressed by half. Okay? All the y values are halved. Okay. There you go. Now, I'm just going to write this over here. We have y is equal to f of, a times f of x over b, whatever number is here, we multiply, but because this time it's in the function, we multiply by the x value. So once again, let's do y is equal to f of x, looks something like this. Okay. Now, that's my original. I'm going to copy that actually. And there you go. Okay, I'm going to copy that. This is y equals f of x over 2. So my b is equal to 2. So all my x values I'm going to multiply by 2 here. Okay. This has a value of 1, so it becomes 2. This has a value of 2, so it becomes 4. This is a value of 3, so it becomes 6. So on and so on. This has a value of 0, so 0 times 2 is still 0. Here, here, here. And we get this. There. So we're basically stretching everything by 2, or expanding by 2. This is where it gets a little bit tricky. Whenever you have a function, whenever you have a function where it's something times x, you have to manipulate it. Instead of writing 2 times x, we can rewrite it as x divided by half. This goes down and it becomes a reciprocal when it's at the bottom. So I want to prove to you that x divided by half is the same thing as 2 times x, because that's x divided by half, which is x times 2 over 1, which is 2x. But when we write it like this, it's a lot easier to see what my b value actually is. So this is y is equal to f of x over half. My b is half, which means we know it's a compression. And because it's inside my function, it's a horizontal compression. So if I have my original function looking like this, then every single x value shrinks when you multiply it by half. Okay, so I'll use this function over here. This is 2. 2 times half is 1. This is 4. 4 times half is 2. This is 6. 6 times half is 3. And we do the same thing for here, here, and here. 0 is still 0, so it looks somewhat like this. So now let's write an equation for the function y equals root x with a vertical expansion by a factor of 2, which means, remember, y is equal to f of x. Anything that has to do with vertically, you put it on the outside. So we're expanding by 2. That means y is equal to 2 times root x. We're compressing by a factor of half. Y is equal to half times root x. If we look at this, we are expanding by a factor of 2. This is y is equal to root x over 2. And compressing by a factor of 2 is y is equal to root x over half. Okay. Some textbooks might want you to write y is equal to root 2x like this, okay. But honestly, not that big a deal. And in fact, I would prefer this method. So let's look at this one. What has happened to y is equal to f of x to produce y is equal to 3 f of x over 4? Well, this is just a vertical expansion by 3 and a horizontal expansion by 4. Moving on, let's say 3, 1 is on y is equal to f of x. What is the point of this? Y is equal to 2f of 4 times x. So rewrite this as y is equal to 2 times f of x over 1 over 4. So we know this is a vertical expansion by 2 and a horizontal compression by 1 over 4. Vertical expansion means you multiply the y value by 2. So the 3, 1, as soon as it's put into the vertical expansion, so let's do, this is original, 3, 1. Vertical expansion by 2 becomes 3, 2. And a horizontal compression by 1/4 is you times the x value by 1 over 4. So that's 3 over 4, 2. And there you go. Describe the following transformation from y is equal to x squared. So if we look over here, y is equal to 4 times x squared. So we know this is a vertical expansion by 4. Okay. If this is your original, okay, and it looks something like this, then your new one is just going to times everything by 4. Right here, right here, right here. I can't times this by 4 because it's going to be 16. Okay? But 1 times 4 is already 4, like we put over here. And you just stretch everything out. Okay? But I want you to notice something over here, because you said this is a vertical expansion by 4. If we look here, okay, y is equal to x over half squared. This is a horizontal compression by half. So the black is our original, and we times all the x values by half. There, here, here, and here. And what you notice is that a vertical expansion by 4 and the horizontal compression by half are the same thing. If you realize it here, okay, y is equal to 2x squared. If you multiply it in, that's 2x times 2x. Y is equal to 4x squared, which completely matches what we were doing here. But it's the way we manipulate it by how we shape it. We can put a fraction over it. We can make it into something like this, right? Depending on how we draw it and depending on how we place the different operations, we might be asked to do different things. However, there's still going to be the same answer. So once again, this is y is equal to x over half squared, which is a horizontal compression by half. I won't give you the tips and tricks to understand how you can go from one to the other, how you can go from horizontal expansion or horizontal compression to vertical expansion, but I want you to know that even if a question asks you for something different, they might be the same, as in this case. I've asked you for 2 different things, and they ended up being the same.